Making automata. This program has been designed to help your students create really imaginative automata. It can also be used to teach mechanisms. Use it on your whiteboard and teach the whole class, or allow your students to be independent, do their research, work out how to mark out and make automata. Here's two typical automata. The one on the left is a 13-year-old piece of work.
Using a large eccentric cam to create all that up and down movement of the ball. Then we've got an eccentric cam which does rotary movement at 90 degrees.
This automata was made by a 15-year-old. They used the program to do the research.
An input via ratchet with a ratio of 1 to 8. A snail cam raises and lowers the linkage to create the golf stroke.
This is one of 5 index screens. It's everything required for your students to move around the program. Looks at automata, shows them design, talks about different types of mechanism, where they're used in everyday life, talks about health and safety. There's lots of homeworks, and one of the most important bits, the bit on top. It's really important that your students work out the required input to get the desired output. Click on the images on the right. This is one of 5 screens. And see what mechanisms are available. The text on the left will take you to that part of the program.
Makes a vertical movement on the shaft, and then the head is going up and down. The body is working as a collar to support the whole shaft.
It's really important that students do good research. Don't allow them just to waste time going around the internet. Use these really good links to research automata and mechanisms. There's some excellent YouTube links as well. This one's a fantastic link which has an animation of an engine, how it works, how it's put together. Good research is really important. This program comes with a fully printable booklet that your students can work from. Get your students to research automata. This will help them come up with a great idea. This is one of 13 screens that has about 120 students' automata. Click on the automata image and your students can look at see how other students have solved the same problem. This is one of more of the screens. This is one of the automata that students made. Lots of movies to explain.
You can see a man trying to catch a rabbit in a rabbit burrow. It's using a snail cam to move the rabbit up and down, and we have an eccentric pulley that's acting as a crank that moves the lead of the fishing rod.
The front screen will show the automata, and then there'll be a number of other screens that explain the theory. Diagrams to help. Excellent images. Most screens has a tips button. This will actually explain it. And also there's often sounds.
This pulley is working as an eccentric crank. It's pulling the string up and down, creating a lever. Here you can see the lever that's moving the cart up and down. Look where the fulcrum is.
Excellent images to explain theory. The bit on top is often very, very difficult. Encourage your students to research this, and this is an example of in the booklet, and this is what the students finally produced.
The automata frog uses a concentric cam to turn the fly around, and a crank that creates the movement of the tongue in and out. See how effective this action actually can be achieved.
Generating good ideas is obviously very important. The booklet has a number of pages on this. Here's an example of some student sketches and their final solution. It's important that your students work out what they want to make. This is a printable Word document that allows your students to design their final solution. Put the shaft in the correct position and then start putting the mechanisms on. This is going to be an eccentric cam, so further off centre it is, the more movement achieved. A collar is always really important. This will be explained clearly in the program. We put a collar on there, and then we're going to put a follower in position. They can add any mechanisms they want. In this case, we're going to put a pulley. Arrows can be put on as well to explain the movement that's going to be achieved. In this case, we're turning rotary movement into reciprocating movement. Print this out and use it as a guide. Here's some more automata. This is one of a student's work. They used a little micro switch to get the indicators to switch on and off.
On the left, which is creating a linear back and forth movement. We have two cams creating a reciprocating movement. And finally we have a low cam that's operating a bridge.
Here's the automator of two judo players. This automator uses two shafts, so they've got two types of movement, front and back of their automator.
Uses a series of eccentric cams to create the movement.
They've used a pulley system to transfer movement from one to the other. It's really important that your students work out what mechanisms are available to produce their automata. This will be explained in real depth. Here's a crank. This crank uses a piece of piano wire, so you can transfer the movement from the crank to the moving bit on top.
You can actually change the direction from the input to the output. You can see here how the arrow is going backwards and forwards.
The making button will take you to that area, and there'll be images on the right to explain where that mechanism has been used. Collars are really important, and your students will have to do this if they want to transfer movement from the mechanism to the bit on top. This simple video will explain the theory.
Not up and down. But if you put a collar in, like so, the collar will allow that cam to move freely.
Marking out is also explained in real depth. This is one of many stages that will show your students how to mark out. In this case, it's a simple gear. Images are used as well to explain the theory behind it and make it relevant. Here's the marking out of a crank. This crank has been marked on paper, and the image on the right explains the different marks and how they're used. Here we have a snail cam. The fall has been divided up and staggered around the cam. There's lots of ways of making the box that your automata sits in. This one shows a jig.
Use a jig to help you glue your box together. It speeds things up. Put wood in there and it will position it for you. Use a clamp it up, then you can take it out. Do it dry, and then when you're happy with it, put the glue in position.
Here we have the crank using the piano wire. This is a typical screen. The tips button will explain the theory of it, and in this case we have 4 images to explain how the stages are made. Also a diagram to explain where the holes are drilled for the piano wire. Here's a typical movie.
Using a bench hook to securely hold your plastic tube, use a junior hacksaw. Just slowly cut through your tube. Cut it as square as you possibly can.
Here's a typical bit on top. It's really important to get that right. In this case, a student has printed out an image, put it on some MDF and used a Hegner saw to cut it out. Images will show the theory of this.
Is transferring rotary movement from the shaft up to the drumsticks. The left hand is a crank connected to a piano wire that is moving the other drumstick up and down using a simple linkage and lever. Here we have a drummer with one arm going up and down and the other one spinning some drumsticks. We have a crank for the input of the arm going up and down and a pulley operating the turning of the drumsticks.
Another way of doing the bit on top is to use modelling magic. That's really effective. There's many problems solved in this program. This particular one shows how you can stop the actual follower turning when the crank has moved up and down.
To stop the cam follower turning, use
The follower has been bent and turned back up through the automata box. This is one of many problems that need to be solved when you're creating automata. This is the final solution. A really nice automata of a caterpillar.
Body up and down. The follower is bent round and back up through a second hole. It stops the body from spinning. It makes it go straight up and down.
The theory of making this is clearly shown. It's important to bend the wire before you drill the holes. Each of the different mechanisms is shown how it's been used in different automata. In this case we have eccentric cams. All these automata have used eccentric cams to be successful. Evaluation is also an important part of the whole design process. There are many printable sheets. This one's a peer evaluation one. Allows students to mark each other's work. Feedback is really, really important and quite difficult when you're doing practical work. There's a printable feedback sheet that students will have. Get your students to write feedback and suggestions that you've made to them. This gives you more time to do the actual less work you've been paid for. There's a really big teachers section showing lots and lots of examples. Here's one example. This is an example of a document that allows you to keep an eye on your progress of your students. It will give marks for both designing and making and attitude, highlight the areas where they're struggling and give examples of where they're doing well. Lesson plans are always set out as well, so there's a whole suite of lesson plans. Teachers section have every bit of paperwork you need to be successful. I hope you found this interesting. Good luck.